Good afternoon, everybody. I'm glad to welcome you on the first in history of EDM Conference Junior Session, dedicated to involvement of youngest specialists in the field of science. So, firstly, I wanted to say a couple words about the event. It is the first event in the history of EDM, and today we will hear four following reports on our session, and some rules listed to ask questions to the speakers only in English. If you want to ask a question, raise a hand. And when you ask a question, please stand up and speak into the microphone. Some information for the speakers. When you have 1 minute left, I will raise I will raise a card. When the time is over, I will raise a card stop. So I think we can begin with the first speaker, Varvara Yaitskaya. Please start.
Good afternoon, dear jurors and participants. My name is Varvara Yaitskaya.
And I'm Nadezhda Sedelnikova.
We are the students of the second Novosibirsk Gymnasium. The topic of our research is the movement of a mobile robot in the environment by means of machine vision system.
Nowadays, the task of a mobile robot navigation in the environment is a priority, since the solution of competitive tasks in robotics is based on the movement of the robot and finding objects within the competitive field. There are several ways of robot orientation on the field: movement by sensor and movement on the camera.
The purpose of the study is to consider the possibility of using machine vision technology to move a robot around. To achieve the goal, we perform the following tasks. Analyze the types of robotic sensor, perform the analysis of machine vision technologies, consider the possibility of replacing the sensors when the mobile robot is navigated in the environment with the help of machine vision technology.
The movement by sensor implies the presence of sensors installed on the robot that can capture the information about the environment, receive signals, and adjust the track based on the received information. The main sensors used are ultrasonic sensor, color tracking sensor, and gyroscope.
We have been taking part in robotics competitions since by youngest age group and noticed that the same types of sensors are used in every age category. Let's consider each of them in different sets: ELT, VXIQ, and Statico.
The first sensor is ultrasonic, which is best suited for the distance measurement, generating high frequency sound wave. It rebounds of objects in the surrounding area and returns to the robot.
Another commonly used sensor is the one that allows you to detect color labels from the field or its elements. As a rule, such sensors are able to detect colors or the accents, work in the mode of determining the level of room illumination, and capture the level of the reflected light.
The gyro sensor is typically used to measure rotational speed, but it can also calculate rotational change.
Today, the robotics includes other ways of obtaining data, such as artificial intelligence method. One of them is machine vision technology, which uses image analysis to solve industrial problems.
A digital camera takes an image and transmits it to a computer. The special software analyzes the image data and sets the tasks for the equipment.
Machine vision technology can replace the operation of all the sensors mentioned above.
Machine vision technology is able to detect colors, measure the angle of deviation, determine objects and the distance to them. The capabilities were used in solving the competitive problems at Young Professionals Oxford Skills Russia Championship in the competence of mobile robots. In the competition task, two robots moved around different parts of the file. One of robots had to read the pack numbers, while the second one had to find and move the packs, according to the positions found by the first robot.
With the help of our research, we can state that all the functions performed by sensors can be replaced by machine vision systems. A universal technology that allows the robot to move in any way around using only one camera instead of a large number of sensors. That's all we wanted to say, and we're ready to ask your questions.
Thank you for your report. Maybe the first question from the audience. Anybody has any questions about the research? Okay. Thank you for your research. And I wanted to ask a question. Does your machine vision system require any sensors for operation or not?
No, thanks for the questions.
Sensors are
You can answer the question by Russian words. We have a translator.
yes.
Но нет, не используются сенсоры в машинном зрении. Ну, в системе машинного зрения не используются сенсоры никак. Только вот
The sensor doesn't use.
Okay, thank you for your answer. Does any questions? Okay.
So, thank you for your report. I have a question. So, do you have some experimental improvement of your system, or it's just your it's just your theory and you just don't have some experimental improvement? Maybe you're planning to build such robots based on this machine learning system.
Но мы имеем небольшой опыт соревнований, мы участвовали в соревновании World Skills Russia, и там использовалось машинное зрение как раз. И вот на основе этого опыта мы делали вот эту свою теорию.
Okay, thank you.
Wait, please translate the answer.
As I understand, the work is in progress and they have some experiment.
Okay, thank you for your answer. Maybe if there are no any questions, we can continue with the next speaker. Thank you. So the next speaker is Alexander Vanyushkin. Please start.
Hello, I'm Alexander Vanyushkin from the Municipal Autonomous Educational Institution, Second Novosibirsk Gymnasium, and I would like to present you a work dedicated to my product. This is a test generator for dual-channel IGBT and MOSFET drivers. So first I will explain what a driver is. The transistor driver is an electronic device. In industry, drivers are manufactured on a huge scale. Only one product may require about 1,000 pieces per year. Moreover, each driver must be checked without fail. Otherwise, there is a risk of failure of the entire expensive product. My task was to create a device for testing drivers for transistors, for testing without using many different other and rare devices. To achieve the goal, the following tasks were set and solved. Develop a block diagram of the device according to the specified requirements. Design a schematic diagram and simulate in multi-sim, make a device, test the device, and develop a technique for checking drivers. The following requirements were presented to the device being developed. Supply voltage from 18 to 24 volts, output frequency 20 kilohertz, output voltage 15 volts, pulse duration 4 and 40 microseconds, pulse type unipolar, and number of outputs 2. As well as switching on off by a button with LED indication, switching the pulse duration by pressing a button at the signals must be in antiphase. You can see my experimental setup here. Digital oscilloscope, DC power supply, test generator, and device under test. Test generator includes power supply unit, on-off indicator, on-off button, duty cycle button, output, and power indicators. Structural scheme. I propose to create the main part of the device based on a multivibrator. The distribution of the pulses to two channels is implemented using NAND logic gates. The same logic block is responsible for the presence or absence of signals and the outputs. After that, on the buffers made of transistors, the 15 volts signals we need are already obtained, which are sent to the output connector. And since it was necessary to connect the 15 volts power lines to this connector, the following was done. A voltage from 18 to 24 volts is applied for the device input. Further, the voltage is converted to 15 and 5 volts using voltage stabilizers. The generator and logic are powered by 5 volts because the NAND microcircuit works only at a voltage of 5 volts, and 15 volts are already going to the buffer. Difficulties arose while thinking about how to implement switching the signal duration without changing the frequency of the generator. And a pretty tricky system was implemented. It changed the charge circuit and the discharge circuit of the capacitor C1. Then everything was simpler, and having a disjunctive NAND circuit implemented two outputs, one of which was fed a signal through an inverter, implemented by shorting two inputs on one NAND element. As buffers, the idea arose to use transistor stages according to the open collector scheme. Experiments. I did some experiments with my device, and as a result I got several measurements. Output signal at switch S2 is off, and output signals at switch S2 is on. Now you can see how the signal duration changed after pressing the switch. Two inputs and two output signals, but due to the lack of opportunity, I gave only one input and one output. And the driver error. Here you can see how the driver goes into protection in the case when no transistors are connected to its output. Summing up, it should be noted that this device helps a lot of when checking drivers for their performance. Although this product can be made even more accurate, it still significantly reduces operating costs. For the future, I have a plan to develop my own methodology for checking drivers with my device, which will also greatly reduce the time and the effort spent working with my device. And now I have everything. Thanks for your attention.
Thank you for your great presentation. So we can start with the questions from the audience. I think then.
Thanks a lot for your great presentation. My question is, where are these drivers used for? What is their application?
Maybe on some factories while checking the products. These drivers for transistors, I said.
Okay, thank you.
Another questions, please? So if there are no questions, I can ask questions about the power level of your device. What's the power level of your device you created?
Maybe supply voltage, you mean?
No, supply voltage times by output current. No, output voltage times by output current.
For about maybe
Which the current level, input current level?
for about 1.8 amperes.
Thank you for your answer. So, is there any questions?
Hello. Does your test schemes realized the dead time for switching, so for switch on and for switch off and next switch on transistor?
I'm currently working on this issue.
Repeat, please.
I'm currently working on this issue.
Okay, thank you.
So, thank you for your questions. Thank you for your presentation. We can move on to the next speaker, Artem Kuznetsov.
Good afternoon, dear judges and participants. My name is Artem Kuznetsov, and I'm a high school student from Second Northwest Gymnasium. The topic of my report is the solution of differential equations and their further application. So, to solve problems in physics, electrical engineering, and other scientific fields, mathematical methods are often used which are not included in the school curriculum. So, the differential equation are one of these methods. So, differential equation is an equation that relates independent variables and a known function and its derivatives or differentials of different orders. So, consider the following problem. There is a circuit consisting of 4 elements: an alternating current source, a resistor, an inductor, and a capacitor. Let's call this circuit RLC. All elements of this circuit are connected in series, so my main goal is to find the voltage of this circuit. According to the first Kirchhoff's law, the current strength is the same in all sections of the circuit. The second Kirchhoff's law states that the algebraic sum of the voltage at node is equal to 0. So the voltage U sub L in the section from 2 to 3 is equal to the product of the inductance and rate of change of the current strength with time. And the current strength in section from 3 to 4 is the rate of change in charge over time, where charge equals the product of inductance and voltage U sub C. So using the Kirchhoff's laws and the obtained equalities, we have the following equation where epsilon over time changes due to the following law. This is a second order linear non-homogeneous differential equation. Well, let's consider its solution. At first, we solve a homogeneous linear equation. The roots of this characteristic equation are real numbers k1 and k2. So if k1 and k2 are complex numbers, then the contour won't work. The solution to the homogeneous equation has the following form. We will find a particular solution of this equation in the form. So let us find the first and second derivatives of this solution and substitute them into the original equation. Let's carry out all the transformations and get a system of 2 linear equations with 2 unknowns, C1 and C2. Thus, the general solution of the original equations takes the following form. To sum up, I would say that this paper acquaints high school students with high mathematics problems, and the described methods helps to solve different problems in physics, electrical engineering, and other fields in an easy way. Thank you for your attention. I'm open up to your questions if you have any.
Okay, thank you for your presentation. And I wanted to ask a speaker about the conclusion of your presentation. Does it have any conclusion slide?
Yeah, that's a conclusion slide you may see here. It's like in the red square. It's like the general solution, but it takes only in theory.
I want you to ask in the future to do a additional slide with the conclusion title and to sum up some your main topics at this slide. Thank you. Are there any questions from the audience?
Yeah, thank you for your presentation. So in your final solution, in your final formula, there are two constants, and how can we find the value of this constant? Can you tell us?
You are talking about key 1 and key 2?
No, about C1, I think, and C2.
C2, we can just solve the system of two linear equations. Like you see.
So, and did you find it? The value of these two constants?
I only did some theory because I don't have any supplies to do it experimentally. And I think in the near future I will do it. I will do an experiment and I will find them out.
Okay, thank you.
Next question from the audience.
Thank you for your presentation, and I have one question for you. And could you outline the type of roots, eigenvalues of characteristical equation for second order case?
Okay, that they have to be real numbers, because if they are not, they are complex numbers, then contour won't work.
Other types of real values and another.
No, just real numbers.
Okay, thank you.
No problem.
So, any other questions? May I ask you a question about the future of your work? Maybe you will design useful, practical, experimental branch for your work.
Yeah, I'm going to do it, and I think I will study it with my mentor.
Okay, thank you. Thank you for your excellent report. The next speaker is Sofia Silina. Is he in the? Is going to present?
He is absent today, and
So,
she's not able to present her presentation.
can you present your presentation? Am I got you right?
I don't think so, because she is absent.
The report, what we don't hear, will hear this report. Yes?
Yeah.
Oh, okay. Thank you. This is the all reports we heard, and I wanted to finish the section, and at the end of our section, I wanted to say that all participants were good at their first scientific work, and looking forward, they will be a great scientist, and I hope that their scientific topics will reflect their bachelor and master's and maybe a PhD theses they will write during their students' year. Thank you all, and goodbye.
Thank you for the conference. Goodbye.